Hello, welcome to Technical Info. Today I am going to perform pulse width modulation. Basically, the pulse width modulation is the modulation technique that generates variable width pulses to represent the amplitude of an analog input signal. So here I am using the module kit PWM 94002 and oscilloscope, function generator for the analog signal or sawtooth signal. So first of all, I am connecting the IP1 in the comparator side. For ground, I am connecting the ground pin in the ground side, and here I am applying the analog signal 1 kHz and the sawtooth waveform. I am connecting the input signal in the IP1 and the ground is also common. So now, after that, the output of the comparator, here I am connecting output side in the input side of the 555 timer IC, and output is taken from this 555 timer IC pin number 3, and ground is also common. So here I am connecting the oscilloscope and channel 1 pin of the oscilloscope connecting in the input side for the input signal, and for the output side I am connecting the channel 2 probe, and ground is common. Here you can see the sawtooth waveform in the input side, okay. Now this is our sawtooth signal which I am applying in the input side is 1 kHz. Here you can see the sawtooth is 1 kHz. Here I am applying, and our waveform of the PWM generator is this kind of shape. This is our output signal, which is given from the 555 timer IC pin number 3, and here you can see when the input side cycle is going down, the pulse width is in the lower side is very low. When it comes in the upper side, the width of the pulse is growing slowly. This is our 3 types of edges. Tail edge of PWM is kept constant. This is our tail edge. Our leading edge of the pulse is also constant, which is here. This side of the edge is calling leading, and the center of the pulse kept constant, which is also constant. So basically, pulse width modulation is a digital signal. Pulse width modulation is actually DC signal. The approximately frequency of the pulse width modulation PWM is 15.625 kHz. Pulse width modulation is the type of modulation the most used for power regulating in DC devices, just of dimming of LED. Like when the LED is dimming and the glowing, it controls of the brushes of motor or switching power supplies, so called the preciously, because the voltage on the load switches continuously in the circuit. So this is our input signal in the comparative side, and I have connected the output from the comparator to the 555 timer IC here, and the output of the 555 timer IC, which is giving us the digital pulse, which is also 0 or 5 volt. The principle of the PWM is consist of 2 main components. The 2 main components are duty cycle. Duty cycle means duration of the cycle is, and the frequency. Both 2 types of components are very important in the PWM. So in this oscilloscope, you can also Now here you can see the input side is amplitude is 5 volt. The output side or frequency of the pulse width modulation is approximately 15 point something. It changes on the pulse, depends on the amplitude. So this way we can perform the pulse width modulation, and actually this is the conversion of the analog to digital signal. So here we are using input signal which is also analog, and the output side, here you can see on the oscilloscope, input side the analog signal is sawtooth wave, and the output side is the digital signal. And here you can measure the frequency and the duty cycle. Duty cycle means the time of the duration which is on and off. Here approximately 75% on and the 25% off. So slowly it is going to up and down. So keep in mind 3 types of edges in this pulse width modulation: tail edge, leading edge, and the center of the pulse. Thank you. Thank you for watching AR Technical Info.